Welcome to today's lesson. We are going to look at speed of sound by echo method. We look at reflection properties of sound waves. Now we start by defining what is this reflected sound. So when you talk or when you clap and you are in an empty room, the walls, the ceilings and the floor will reflect your sound. And that reflected sound is called echo. Now, reflected sound is more pronounced when it hits the hard surface, like wood, stone, and metal surfaces. But when it comes to the liquid surface, the reflection is weaker. Then we have another term, reverberation. Sometimes you may find that when you are room and the time taken for the reflection to take place is short, the original sound overlaps with the echo. So what you hear is a prolonged sound. This is what we call reverberation, where the original sound overlaps with the echo, and as a result, we have a prolonged sound. This again, we are saying it occurs when echo time is short. Then to reduce reverberation, especially in broadcasting studios and concert halls, you find that the walls are made using absorbent. This means that they will absorb sound. Absorbent materials like cotton wool or foam rubber. Then we move to experiment. Now in this experiment, we want to demonstrate reflection of sound. We have two plastic tubes, a ticking clock, and a smooth hard surface. Procedure number 1. Place the clock near the end of one of the tubes as shown below. We have the tubes. These are the empty tubes, plastic tubes. We have the clock here. The clock is producing sound. Then this is our wall. So you are making sure that your tube is facing wall at a given angle. This angle is what we call the angle of incidence, if you can recall the reflection of light in Form 1. This is normal. And now we have the reflected sound wave. So this angle between the normal and your plastic tube will give us the angle of reflection. Now this one is supposed to produce sound, and you as the viewer, you are supposed to listen. You are supposed to change the position of this plastic tube until you hear the place where the sound is loudest. Then when you get that point, you're supposed to measure this angle and this angle, and then you can make your conclusion. So we move to procedure number 2. Point the open end of the tube towards a hard wall at an angle of incident I. With the ear close to one end of the second open tube, listen to the reflection of the sound from the wall at different angles of reflection. And again, note the angle at which the reflected sound is loudest. Our observation. It is observed that maximum loudness of the reflected sound occurs when 1. The angle of reflection equals to the angle of incidence. Both tubes and the normal to the reflecting surface lie in the same plane. Now, if you look at these observations, they are familiar and they give us our conclusion where we say that sound waves obeys laws of reflection. And we have that the laws of reflection states that number 1, the angle of incidence is equal to the angle of reflection at the point of incidence. Number 2, the incident sound, the reflected sound and the normal lie on the same plane. So it means that the laws of reflection that we learned in reflection of light in Form 1 also applies here in sound. We move to determination of speed of sound. And in this case, we consider a person who is producing sound and his or she is at a distance d from the obstacle. So this person is supposed to have a stopwatch to gather time. And now what happens is that the sound is produced from here. It moves to where we have the obstacle, and then it moves back to her where she hears the echo. So using the stopwatch, she makes or records the time. Now, to get the speed, we always know that speed is given by distance over time. So we take the distance traveled divided by the time taken. But if you look at our experiment or our case here, the sound is traveling this distance d and then back to her. So this distance is covered twice. So our total distance covered will be twice d divided by t. So that way you are able to get the speed of sound. We move to an example. An echo sounder produces a pulse and an echo is received from the seabed after 0.4 seconds. If the speed of sound in water is 1,500 meters per second, calculate the depth of the seabed. We proceed as follows. We have just seen that speed of sound is twice d over t. So we substitute our values. We have the speed is 1,500, then twice d divided by the time taken, which is 0.4 seconds. After that, we want to get the value of d. So first of all, we eliminate our denominator by multiplying both sides by 0.4. So you have twice d is equals to 0.4 times 1,500 meters. Now to get the value of d, you divide through by 2. You get that the distance or the depth is 300 meters. Another example. A person watching a miner sees the miner strike the rock and hears the sound 2 seconds later. Determine the distance between the person and the miner, and you're given the speed of sound as 340 meters per second. Now, we have this. Distance is equals to speed times time. This one is just direct. You substitute the speed, which is 340, and the time is 2 seconds. So you get that the distance is 680 meters. Another example. A man standing in a valley between 2 cliffs strikes a gong. He hears an echo from one cliff 0.7 later, and from the other 0.2 seconds after the first. Determine the width of the valley. This is the presentation of our case here. You have the 2 cliffs or the 2 valleys. Then the person is in here. So we take the distance from the nearest cliff to be x, the distance between the 2 cliffs to be d. So automatically the distance from here to the farthest cliff will be d minus x. So we proceed as follows. Distance is speed times time. The speed is given. But remember, we are taking the distance to be twice because the sound will have traveled twice this distance. So 2x is equals to speed of sound 330 meters per second multiplied by the time taken, which is 0.7 seconds. When you multiply this, you will get that to get the value of x, you need to divide by 2. You get that x is 115.5 meters. Then we move to the second part. The distance is now d minus x. So it is twice the distance, which is equals to 330, that is our speed, then the time. The time for the second echo is heard 0.2 seconds after. So the total time taken will be the first time plus 0.2. So by multiplying and adding, you will find that your d will be 297 divided by 2, then plus the value of x. And the value of x here is 115.5. So when you add them, you get that the D is 264. That is the distance between the two cliffs. We move to another example. A timekeeper in 100-meter race starts at the finishing point. He starts his watch the moment he hears the sound of a gun. What error does he make in timing the race? Remember, he is starting at the finishing point. So we have that the error is equal to the time taken for the sound of the gun to reach the timekeeper. So it means that that sound will have traveled these 100 meters. And we have the speed of sound as 330 meters per second. So our time is always given by speed over the distance over speed. So you have distance, which is 100 meters, divided by speed, which is 330 meters per second. So when you divide, you get that it is 0.303 seconds. Now this will be now the error the man is making. We move to determination of distances by producing sound of a known speed, and this one we are going to use pass echo technique. Now this one involves measuring distances by producing sound of a known speed. So you know the speed and you have the time, therefore you can be able to get this distance or the depth. Now ultrasound, that is sound of frequency of over 20 kilohertz. When we talk of kilo, it means that it is times 10 to power 3. So this will be 20,000 hertz, a very high frequency. So we use this ultrasound in pass echo technique. And the reason is because it penetrates deepest and it can be reflected easily by tiny grains. So we look at applications of pass echo technique. 1, it is used in ship to determine the depth of the sea. It is used in underwater exploration of gas and oil because it is reflected by this. In fishing boats, this can be used to locate shoals of fish. It is used in a special type of spectacles, and these ones are used by blind people so that it can help them tell, or it can tell them how far the objects are ahead of them. Then it is used by bats to detect the presence of obstacles in their flight path. We look at an example. The first one. The ship sends out an ultrasound whose echo is received after 10 seconds. If the wavelength of the ultrasound in water is 0.05 meters and the frequency of the transmitter is 50 kilohertz, calculate the depth of the ocean. We proceed as follows. We have this formula. Velocity of the waves is equals to wavelength times frequency. This one we call it the wave formula. It was studied in waves 1. Now we just substitute our values. The wavelength is given as 0.05 meters. The frequency is 50 kilohertz, so it is 50,000. When you multiply, you get that the velocity is 2,500 meters per second. But the question is asking about depth, so we proceed. The twice d is equals to velocity times time. So we have our twice d, because now that one will have traveled and then back, is equals to 2,500 meters per second times 10. Then to get d, you divide this value by 2. Remember, this was twice d. Now when you divide, you get that the distance or the depth is 12,500 meters. Then another example. 2 boys stand 200 meters from a wall. One bangs 2 pieces of wood together while the second one starts a stopwatch and stops it when he hears the echo. If the time shown on the stopwatch is 1.2 seconds, calculate the speed of sound. We have that the speed of sound is twice d over t. Our d is 200 meters. So 2 times 200 divided by the time taken, which is 1.2 seconds, you get that the speed of sound will be 333.3 meters per second. Then we have assignment. This one is calculations. Most of them is asking you to calculate. Make sure that you do the practice before you attempt. Practice makes perfect. Don't just go and try to recopy. Get the answers from your mind. Evaluate yourself. So thank you, and let us meet in our next lesson.